Welcome to Akshara IIT Foundation. Myself Shivashankar. So today we will start a new chapter. In the last class we have completed vernier calipers. We have completed there and we have done the numericals. The next topic is vectors. Next chapter is vectors. So this is in page number 1, synopsis 1. In page number 49, synopsis 1 there. Okay. So we'll see their vectors. So in the physics, we will be come across there are many physical quantities, like we'll discuss distance, displacement, velocity, acceleration, then force, okay, like linear momentum, pressure, work done. So like there are many physical quantities we will be seen there, okay. So from that all the physical quantities, these all physical quantities are classified into two types. They are vector physical quantities and scalar physical quantities. Okay, vector physical quantities and scalar physical quantities. So vector physical quantities are nothing but we'll say the physical quantities which have both magnitude and direction. Both magnitude and direction. The physical quantities which have both magnitude and direction, they are known as the vector physical quantities. The physical quantities which have only the magnitude, there is no direction, then those physical quantities are known as scalars. Okay. So now here in this chapter we are going to see only the vectors. So how the vectors can be represented and how the vectors can be added. So the vectors cannot be added like normal algebraic functions. Okay. So like we will use when we are doing the algebraic equations, we can add normally the scalars can be added in the by using the algebraic laws, but here the vectors cannot be added like that because they have both magnitude and direction there. So there are the vector laws, vector law of additions will be there. Based on that laws we have to add them. Okay. So now we'll see there how the vectors can be represented and how it can be denoted, then how the magnitude can be calculated, how the direction of the vectors can be calculated, that and all we are going to see. Okay. So these vectors are classified into two types, means we have a physical quantities, all the physical quantities, all the physical quantities are classified into two types. So they are, first one, vector physical quantities, and second one is a scalar physical quantities. Nice. So we'll see here vector physical quantities, then scalar physical quantity. Then vector physical quantities are nothing but the physical quantities which have both magnitude and direction. Okay. Now we'll see there one by one. So first one is vectors. So vector physical quantities are simply they are said to be the vectors. Okay. And scalar physical quantities, they are simply said to the scalars there. So now vectors are nothing but the physical quantities which have both magnitude and direction. The physical quantities which have both magnitude and direction. So here what is the meaning of magnitude? We are saying here magnitude. Direction means, so in which direction the object is moving, by that we can say it is a direction there. So then what is the magnitude? For any physical quantity, there is a magnitude will be present there. It is a like numerical value and their unit. So any physical quantity can be measured in the numerical value. No, suppose the length is there, length of an object. So length of a room. Okay, so length of a room, length of a trunk of a tree. So like that. So for any physical quantity, suppose mass is there. Mass can be measured by in the kgs. No, so then to measure the mass, like if you take a 1 kg of sugar, so to measure the mass of an object, we will use a magnitude there. Means that magnitude will contain numerical value and followed by its unit. So now here the magnitude is nothing but magnitude. Magnitude is the numerical value, the numerical value followed by its unit, its unit is called magnitude. Like suppose, so mass, for mass will let in kgs, it will measure in kgs. So mass of like example we'll take here. So mass of 2 kg sugar. So 2 kg in a packet. So the sugar has in a packet 2 kg. So here 2 and kg, numerical value and followed by its unit. That is called the magnitude. Okay. So then suppose the length. Ravi has travelled 2 kilometers, 3 kilometers to his school. So here 3 kilometers length, he travelled 3 kilometers. To go to the school, he need to travel 3 kilometers. 3 kilometers length. So now length is expressing in terms of magnitude, that is numerical value and unit followed by its unit. That is called the magnitude there. Like every physical quantity in our day-to-day life, what are the physical quantities we'll use there? We'll use their magnitude. So that every physical quantity will be there in its magnitude. Okay, and some of the physical quantities, they have the direction also. Suppose here in this example, Ravi has travelled 3 kilometers to his school. In which direction? So he will travel. So to travel to his school, to go to his school, there is a particular direction. There are many directions will be there from his home to school there. But in particular direction, if you go there, there is a shortest way will be get there. So like that, there is a distance, there is a direction also will be present there for the some of the physical quantities. Those whose the physical quantities which have both the magnitude and direction, they are called as vectors. So here we can take the examples of vectors. So there are a lot of examples are there for the vectors. Like we have a displacement is a vector there. Then velocity is a vector, acceleration is a vector, force is a vector, and linear momentum is a vector, angular momentum is a vector, torque is a vector. These are all the physical quantities which we are going to use in our topic, in our concepts in the physics. Okay. So those all the physical quantities have both magnitude and direction there. Okay. So those physical quantities are known as here vectors. Now we'll see the scalars. So scalar physical quantities. So scalar physical quantities are nothing but the physical quantities which have only the magnitude, no direction. Okay, they are known as a scalar physical quantities. The physical quantities which have only magnitude, there is no direction, are known as scalars. Okay. Scalars. Now we'll see the scalars. Scalars, the physical quantities, the physical quantities which have only magnitude and there is no direction. Only magnitude and there is no direction. Only magnitude and there is no direction. Are known as scalars. Scalar physical quantities. Scalars. So they have only magnitude. There is no direction. Suppose. So if a person is moving from one place to other place, suppose a boy is traveling in a car from Hyderabad to Tirupati. So while he is traveling from Hyderabad to Tirupati, so it is a certain distance from Hyderabad to Tirupati. There is some kilometers will be there. Like let us take here 600 kilometers per suppose. So then the 600 kilometers, to travel 600 kilometers, there are many directions are involved there. We cannot specify a particular direction. So in that cases, we will say it is a no direction. Okay. So like that, the physical quantities for which we can have only the magnitude and we cannot specify a direction, then they are known as the scalars. So which has only the magnitude, there is no direction. Okay. They are known as the scalars there. So here the examples of scalars we have, like a mass is a scalar term and time is also scalar, mass, time. Then we can say here distance is a scalar. Then speed, work done, work volume is a scalar quantity. Density is also scalar quantity. Like pressure is a scalar quantity. Power is also scalar quantity. Okay. Like there are many, etc. There are many physical quantities which have only the magnitude, there is no direction there. We cannot specify the direction for the physical quantities. Those are known as scalar physical quantities. Okay. So now these scalars can be added and subtracted and multiplied by using normal algebraic laws. Okay. In the algebra how we will be add and subtract the same way we can do here for the scalars. We can add them in the same manner of the algebraic laws. By using the algebraic laws we can subtract addition of the scalars and multiplication of the scalars and division of the scalars we can do there. Okay. So now we will see there. So in this topic we are going to see particularly about the vectors and how the vector can be denoted and how can we find out the magnitude of that and how can we find out the direction of that vector, that we are going to see there, and how the vector can be represented, okay, in a one-dimensional plane and in a two-dimensional plane, in three-dimensional plane. So how the vectors can be written, then how the vector magnitude can be find out, that we are going to see, and what are the types of vectors we have, that all we are going to discuss in this class. Okay. So now next we'll see there denotion of the vector or representation of a vector. So how the vector can be represented. We have seen there the examples of the vectors. They are like displacement is there. So how the vector can be represented. The representation of vectors. Or we can say denotion of vector. So how it is denoted? Suppose the displacement is a vector and velocity is a vector, acceleration is a vector, force is a vector. How can we represent that? Suppose the vector is there, displacement. displacement, we know that it can be denoted by d or s. D or s. It can be denoted by d or s. So if it is a vector, the vector means we'll write the alphabet overheaded by an arrow. This is the displacement. Normally, if you distance and displacement both will be represented by d and s. If the bar is mentioned over the alphabet, then we can say that will be that is a denotation of the vectors. We can say that is a d is a vector, it is now, and s is also a vector. So like suppose the velocity is there, so v bar, suppose if it is a v, then we can consider it as a scalar. Now if it is denoted by the arrow, overheaded by an arrow, then that will be the velocity. So in the same way, acceleration also, for any physical quantities, we can be represent that alphabet overheaded by an arrow, then that will be the representation or denotation of the vectors, okay, or it can be written bold. So by the bold letters also the vectors can be represented by the bold letter. So here we will write bold letter, the font size, it will be size of the alphabet will be greater, or we can write here yes. So this, so bold letter. Sometimes it may not be represented with the arrow, simply it is represented by bold letter. This, that also, in that way also we can represent a vector there. Okay. So then magnitude, we have said magnitude here, how to find out how the magnitude can be denoted. So magnitude can be denoted like this: magnitude of a vector, it can be denoted like, so modulus of d bar, suppose displacement is there, we can write here modulus of displacement, or simply a letter there, displacement. So if you write without any modulus and vector, if you write here vector, then we keep here modulus, then this modulus will give the magnitude of the displacement there. And normally with the simple letter, only the letter, if you write the letter, that will be give the magnitude, it will be represent the denotation of the magnitude there. Okay. So then so how the vector can be represented in one dimensional plane, how the vector can be represented in one dimensional plane, we will see there. The representation of a vector in one dimensional plane, one dimensional plane, okay, 1D. So means a person is traveling from here, from A to B in one direction, in particular direction. Like let us consider here in this direction, from left to right, here it is B. Let us see here, the vector is represented like this, from A to B, So it is, the person is moving from A to B there, A to B. Okay. So suppose if it is a displacement distance, so AB, simply if we write, we will get here it is a distance there. Distance means it is a scalar quantity, distance. Then in the vector form, we can write here, so AB bar, then now AB bar can be represented as a displacement. Now if it is moving in the one dimensional plane, so in one dimensional plane, suppose if you take the coordinate system like this is the x-axis and y-axis, this is only along the x-plane. If the body is moving along the x-plane, then now this displacement, this length can be denoted by an arrow. A straight line denoted by arrow in the one dimensional plane. A straight line will be drawn from the initial point to the final point of the object and a straight line can be done, and there the arrow mark will be represented. This arrow mark will be denotes the direction. It represents the direction in which it is moving there. Okay. Suppose here it is a x direction. If the particle is moving along x direction, certain magnitude, if you take the magnitude here, suppose here 2 meters, 2 meters is the magnitude. So it is moving along positive x direction. If it is moving along positive x direction, then this vector, let us see here, a bar can be written as, now a vector can be written as a bar is equals to, we will write here magnitude of the vector, means only the numerical value, and though it is moving along x direction, this is x direction, no? Along x direction. So here we will be consider the direction for every vector. So for that we need this one. This is a normal, it is a right side east, and top it is a north, down south, and here left side is a west there. And it is moving towards east, and that east is along the positive x direction. If it is a positive x direction, to represent this displacement along the positive x direction with the magnitude in the vector form, we can write here, this is a magnitude. So magnitude will write here 2 meters, magnitude will be the numerical value will write here. Okay, numerical value 2 meters, and we can write here 2 meters also, no problem. And this magnitude will be multiplied by the unit vector along the in one dimensional plane in which it is moving there. So it is moving here along x axis. Along the x axis, unit vector is the I cap. Unit vector is the I cap. So here I cap will get there. Unit vector along the y axis is the j cap there. Suppose if the body is moving along the y axis, then will represent the magnitude, how much distance, how much displacement it has taken place into the unit vector along that y direction. So unit vector along the y direction is j cap. Okay, I said here unit vector. Unit vector. What is the unit vector? So unit vector is nothing but we will be discuss these types of vectors. In the types of vectors, this about the unit vector will come there. Then you will be understand there. Okay. To write the displacement, to write any physical quantity, to represent any physical quantity, will represent like this: a bar, ab bar. Suppose here ab is a vector. Displacement we have taken the displacement vector along the positive x direction. So that vector can be written as here 2 meters into I cap. So we can consider here 2 meters. Let us say here it is a displacement. Okay, let us consider here s, or even we can consider with x also, no problem. Then this vector, the formula of the means the vector form, it can be written as s into I cap, or it is also we can write here x into I cap. X into I cap. So now AB bar is equals to x into I cap. Suppose if the body is moving along the y axis, So let us consider the body is moving like this from here A to B. It is traveling a distance of, suppose here we can consider x is equals to, let us consider this, the distance is here, let us consider y is equals to 4 meters suppose. Then, so the representation, vector representation can be written as, so AB bar is equals to magnitude of this vector, 4 meters into the unit vector. We should multiply the unit vectors. So then that will be give the vector representation. This is the AB, and here 4 meters into j cap. So this will be give the representation of vector in one dimensional plane. Understood, no? So in that way we can represent. So here we can write, so along x axis, suppose the body is moving along x axis, certain magnitude here, suppose x meters, then the magnitude has to be multiplied with the unit vector along that direction. If it is moving along the positive x direction. Suppose if it is moving, so now this is a vector form of the displacement vector. And if it is moving in a negative x direction, this we have to take the negative x direction, minus I cap we should multiply. Okay, suppose if it is moving, a body is moving along the y axis, then so it can be represented along the y axis. Suppose it is moving y meters, So this magnitude is multiplied with the unit vector. Okay, so therefore here AB bar can be written as AB bar is equals to y j cap meters, y j cap meters. So here also we can represent AB bar is equals to xi cap meters, xi cap meters. Like this, we will be represent a vector in the two-dimensional plane. Sorry, in one-dimensional plane. The vector can be represented in one-dimensional plane. So any vector, any physical quantity, okay, any physical quantity can be represented by its alpha beta and overridden by an alphabet, and in the vector form we will write there magnitude of the physical quantity along in which direction it is moving, along that direction the unit vector, if it is multiplied, then we will get the vector representation. So this is a AB bar is equals to x meters I cap means xi cap meters. This will be in the meters there. So this is a, now it is a multiply, now this is a vector, it has a units. Magnitude will be multiplied with the unit vector along the direction in which it is moving there. So that is called the vector. Okay, it is a representation of vector in one-dimensional plane. Okay, understood, no? So then now magnitude of that, here the magnitude simply we can take here this one only. So here x meters in x direction, y meters in y direction along the vertical direction. So that will be the magnitude, it will be set. Now we will see how the vector, how this vector can be represented in two-dimensional plane. We are going to see there. So before going to that, we will be see there types of vectors. There are different types of vectors are there, that we will see one by one. Okay. Now types of vectors. So next topic is types of vectors. Types of vectors. There are different types of vectors are there. So in that first one, we have seen there first one we have seen there unit vector will come with that unit vector only. So unit vector. So what is a unit vector? The vector which has its magnitude is equal to 1. The vector which has its magnitude is equals to 1. Then we can say that it is a unit vector. Okay. The vector which has a unit magnitude is called unit vector. Unit magnitude is nothing but the magnitude of that vector is equal to 1. If the vector has a magnitude is 1, then we can say that is a unit vector. So this a unit vector, suppose here a vector is there, suppose the a vector is there, this is a a vector, it is like this is a vector, suppose this is a vector, let us consider it as a displacement or any vector. The vector can be drawn by this length line, straight line and arrow mark represents the direction of the motion of the physical quantity, in which direction, motion of the body, in which direction it is moving there. And this length, the length of the vector, it will be represent the magnitude, how much magnitude is there. So here the length of the straight line is increases, then magnitude also increases there, and this will be show the direction there. Arrow mark will be show the direction. This vector will have this will be head and tail will say here the front, but arrow mark will be the head and this pointed most this point. Okay, other point of the straight line is called as a tail. Okay, so now the vector, this vector, unit vector of this, suppose this vector has a magnitude, means here this vector has a magnitude modulus of a is equals to 1. If magnitude of this vector is 1, then this a bar can be represented, can be denoted as a cap. A cap. So any vector, to find out that vector means, so we should find out here unit, we'll write here unit vector A cap. It can be denoted by the A and overrated by a cap. So here we'll write the A cap. So that is the unit vector. This unit vector formula can be written as here modulus of A bar by modulus of A bar by modulus of A bar. This is a formula for the unit vector. This will be the formula for the unit vector. So here unit vector can be represented is A cap. So A cap is equals to, the formula of the A cap is A bar by modulus of A bar. A bar by modulus of A bar. That is the unit vector. So next type of vector is, next one we have a like vectors. Like vectors. So like vectors are nothing but the vectors which has the same direction. The vectors which has same direction. They are known as like vectors. The magnitude may be different, but they are in the same directions. The vectors, the two or more vectors, the vectors, two or more vectors we can say, which are in the same direction, which are in the same direction, and the magnitude may be different. And the magnitude may be different. Magnitude may be different. So those vectors are known as like vectors. Suppose let us consider here A bar, this vector is in this direction, and B bar, the vector is in the same direction, and C bar, it is there like this, C bar in the same direction there. Okay. So this type of vectors are known as, they are known as like vectors. Okay. So next one we have the unlike vectors. So just opposite to this, the vectors which are different in direction, the vector which are in the different directions, then they are known as unlike vectors. Third one, unlike vectors. The vectors which are in different direction, are known as unlike vector. Different direction and their magnitude may be different. Magnitude also may be different there. So those vectors are known as unlike vectors. Suppose A bar is like this. This is a bar vector, and B bar vector, it may be like this with a different magnitude in opposite direction or in the different directions. So you can consider like this also. This is also in different direction only, no? Direction will be different there. So the same side, but it is making, direction means it should be the angle. We will take the exact angle there, okay, like this. They are known as the unlike vectors. Next we have a equal vector. We have the equal vector there. So next type of vector is equal vector. Equal vectors. So the vectors which have same magnitude and direction. The vectors which have same magnitude, say magnitude and direction, are known as equal vectors. So let us see here two vectors. Let us consider a bar. This a bar is like this, and b bar, suppose if we consider, this is also in the same direction and equal in the magnitude. The two vectors are in the same direction, they will have the same magnitude. Then they are known as equal vectors. In like vectors and unlike vectors, they are in the different. Like vectors means the two or more vectors are in the same direction, they are said to be the like vectors. And if the vectors, two or more vectors in opposite direction, then they are said to be the unlike vector, their magnitude may be different. Okay. So next type of vector is here negative vector. So next fifth one is negative vector. Negative vector. Negative vector. The vectors which have equal in magnitude, the vector which are equal in magnitude and in opposite direction, and the direction is in and having the opposite direction. Are said to be the negative vectors. Okay, so they will have the equal in magnitude and they will be in opposite direction there. Suppose let us consider here a bar, it is there in this direction, and b bar is the negative vector. If the b bar is the negative vector of that, then it has a equal in magnitude, but it is in opposite direction there. Now, so here we can write there a bar is equals to minus of b bar. A bar is equals to minus of b bar. It can be represented like this equation there. They are equal in magnitude but in opposite direction. This minus indicates it is in the opposite direction. Minus indicates that vector will be in the opposite direction. Okay. So that is about the negative vectors. Then we have the vectors here. Next type of vectors, parallel vectors and unparalleled vectors. Parallel vectors. Sixth type of vectors are parallel vectors. So parallel vectors are nothing but the vectors which are in the same direction or the same magnitude, and all should be parallel to each other. Then we can say they are the parallel vectors. The vectors which are parallel to each other. The vectors which are parallel to each other. Parallel to each other. The vector which are parallel to each other are known as parallel vectors. So here they should be parallel to each other. The magnitude may be equal or not equal. Okay, and the direction also may be equal, maybe in the same direction or it may be in the opposite direction. So they are parallel to each other there. Okay, they are parallel to each other. Suppose let us see here two vectors are in the same direction and this vector is in the same direction. Okay, so they are the parallel vectors. Suppose the vector is like this another vector is in opposite direction, and another vector is in this direction. The magnitude may be different and the direction also may be different, but they are in the parallel to each other. They should be parallel to each other there. So those vectors are known as parallel vectors there. Now the angle between the parallel vectors will be 0. The direction of the two different vectors, parallel vectors, will be 0 there. Or the direction, suppose they are in opposite direction, the angle will be here 180 degrees. Okay, if they are in the same direction, it will be the angle between these three vectors will be the 0, and here these two are in opposite direction, the angle between them it will be 180 degrees. Okay, that we will be see in the direction of the vectors. How to find out the direction of the vectors there. Okay, so here we can say all the like vectors. We have seen the like vectors, no? Like vectors. So this parallel vectors may be the like vectors. Okay, this parallel vectors may be the like vectors, but all the like vectors may not be parallel there, because so all the like vectors may be parallel, then but all the parallel vectors may not be the like vectors there. Okay, all the parallel vectors may be like vectors. Suppose the vectors are in the same direction, then we can say that they are the like vectors. These are all the like vectors, but here we cannot say they are the like vectors. Okay, so all the like vectors, they may be parallel. Okay, so this is about the parallel vectors. Then we will see their unparalleled vectors. Okay, unparalleled vectors, and there are different types of more different types of vectors are there. We will see them in the next class. Thank you, children. Thank you.